Uh, micro, Microeconomics, Section 2.1, the demand function. The demand function shows the correspondence between the quantity demanded, price, and other factors that influence purchases. For example, the demand function might be capital Q equals capital D of P sub S, P sub C, capital Y. 2.1, where capital Q is the quantity demanded of a particular good in a given time period. P is its price per unit of the good. P sub S is the price per unit of a substitute good, a good that might be consumed instead of this good. P sub C, the price per unit of a complementary good, a good that might be consumed jointly with this good, such as such as cream with coffee. And capital Y is consumer's income. An example of the estimated demand function for processed pork in Canada, superscript 2, it reads, because prices, quantities, and other factors change simultaneously over time, economists used statistical techniques to hold constant the effects of factors other than the price of the good so that they can determine how price affects the quantity demanded. See the see the regression appendix at the end of this book. Mocchini and Mielke, 1992, used such techniques to estimate the pork demand curve in equation 2.2. I've rounded the number slightly for simplicity, as with any estimate, their estimates are probably more accurate in the observed range of pork prices, $1 to $6 per kilogram, than at the very high or very low prices. Capital Q equals 171 minus 120p plus 20, capital Q equals 171 minus 20p plus 20p sub B plus 3p sub C plus 2y, 2.2, where capital Q is the quantity of pork demanded in millions of kilograms of dressed cold pork carcass or weight per year. P is the price of pork in Canadian dollars per kilogram. P sub B is the price of beef, a substitute good, in dollars per kilogram. P sub C is the price of chicken, another substitute good, in dollars per kilogram. And capital Y is the income of consumers in dollars per year. Any other factors that are not explicitly listed in the demand function are assumed to be irrelevant, such as the price of llamas in Peru, or held constant, such as the price of fish. Usually, we're primarily interested in the relationship between the quantity demanded and the price of the good. That is, we want to know the relationship between the quantity demanded and price, holding all other factors constant. For example, we could set P sub B, P sub C, and capital Y at their averages over the period sustained. P sub B equals $4 per kilogram. P sub C equals 3 and 1/3 dollars per kilogram, and capital Y equals $12.5 thousand. If we substitute these values for P sub B, P sub C, and capital Y in equation 2.2, we can rewrite the quantity demanded as a function of only the price of pork. Capital Q equals 171 minus 20p plus 20p sub B plus 3p sub C plus 2y, which equals 171 minus 20p plus open parentheses 20 times 4 close parentheses plus open parentheses 3 times 3 and 1/3 close parentheses plus open parentheses 2 times 12.5 close parentheses, equation 2.3, equals 286 minus 20p equals capital D of capital D of P. We can graphically show this relationship. Capital Q equals capital D of P equals 286 minus 280p between the quantity demanded and price. A demand curve is a plot of the demand function that shows the quantity demanded at each possible price, holding constant the other factors that influence purchases. Figure 2.1 shows the estimated demand curve, capital D sub 1, for processed pork in Canada. Uh, Although this demand curve is a straight line, demand curves can be smooth curves or wavy lines. By convention, the vertical axis of the graph measures the price P per unit of the good, which in our pork example is dollars per kilogram, kg. The horizontal axis measures the quantity, capital Q, of the good per physical measure of the good per time period, and which in this case is millions of kilograms of dressed cold pork carcass per year. Skipping to figure 2.1, a demand curve. It reads the estimated demand curve, capital D, superscript 1, for processed pork in Canada, Moschini and Mielke, 1992, shows the relationship between the quantity demanded per year and the price per kilogram. The downward slope of the demand curve shows that holding other factors that influence demand constant, consumers demand less of a good when its price is high and more when the price is low. A change in price causes a movement along the demand curve. We have vertical axis with P, which is dollars per kilogram. On the vertical axis, on the horizontal axis, we have capital Q, which is millions of kilograms per pork per year. Horizontal axis intersected at 286. Vertical axis intersected at 1430. The demand curve, capital D superscript 1, hits the price vertical axis at $14.30, indicating that no quantity is demanded when the price is $14.30 per kilogram or higher. Using equation 2.3, if we set capital Q equals 286 minus 20p equals 0, we find that the demand curve hits the price axis at P equals 286 over 20 equals 1430. The demand curve hits the horizontal quantity axis at 286 million kilograms, the amount of pork that consumers want if the price is 0. If we set the price equal to 0 in equation 2.3, we find that the quantity demanded is capital Q equals 286 minus open parentheses 20 times 0 close parentheses equals 286 superscript 3. It reads, economists typically do not state the relevant physical and time period measures unless these measures are particularly useful in context. I generally follow this convention and refer to the price as, say, $3.30 with the per kilogram understood, and the quantity 220 with the millions kilograms per year understood. By plugging the particular values for P in the figure into the demand equation, we can determine the corresponding quantities. For example, if P equals $3.30, then capital Q equals 286 minus open parentheses 20 times 3.30 equals 220.